So in this video we're going to look at an example where we do a long division before we try to integrate using the log rule for integration. So here I have the antiderivative of 2x cubed plus 3x squared plus 2 all over x cubed plus 1. And this is dx. And as I indicated in a previous video, if you have a rational function, the first thing that you want to do is look at the degree of the numerator. So in this case I have a third degree polynomial numerator, and the degree of the denominator. In this case I have a third degree polynomial denominator. And if the degree of the numerator is greater than or equal to the degree of the denominator, then you want to do a polynomial long division, usually before you try integrating. I mean, you could think about trying to do a u substitution, but what you want to notice is that if you do a u substitution for the denominator, which we've been doing in some of the previous examples, you're going to get du dx equals 3x squared, which is sitting here, but it doesn't differ. It doesn't differ from the numerator by just a constant. In fact, it differs from the numerator by more than one term. So how do I want to say this? A u substitution, isn't going to be incredibly useful in this particular case. So you could try it, but you're going to run into a dead end because the numerator doesn't differ from the derivative of the denominator by only a constant. So in this case, I see that the degree of the numerator matches the degree of the denominator, and that tells me I want to do a long division. So I'm going to take x cubed plus 1, and I'm going to divide it into the numerator. 2x cubed plus 3x squared plus 2. And then I look at this and I say, hey, I'm going to need to multiply x cubed plus 1 by 2, which is a constant, so it's going to go over in the constants column. And if I do that, I get 2 times x cubed is 2x cubed, plus 2 times 1 is 2, so plus 2. That goes in the constants column, and it's long division, so we do the subtraction. So I get 2x cubed minus 2x cubed is 0. 2 minus 2 is 0, and that's going to leave me with just a 3x squared. And in polynomial long division, as soon as the remainder has a degree less than the divisor, you stop. You're done with the polynomial long division. And what this tells us is that the ratio, the rational function 2x cubed plus 3x squared plus 2 over x cubed plus 1 can be rewritten as 2 plus the remainder 3x squared over the divisor. So it works just like regular long division. It's quotient plus remainder over divisor. So I can replace in my integral, I can replace the rational function that I see here with 2 plus 3x squared over x cubed plus 1. And this need to do a polynomial long division before integrating is common. This occurs repeatedly. So then I want to look at this and say, hey, do I know how to integrate this? Well, I know how to integrate a 2 with respect to 2x. And then here I want to notice that the numerator is exactly the derivative of the denominator. The derivative of x cubed plus 1 is 3x squared. So I have that crap prime over crap form, that quotient form we looked at in a previous video. So now I know that I'm able to integrate this. The antiderivative of 2, or a antiderivative of 2 with respect to x is 2x. Plus this is the quotient form crap prime over crap, so it's going to be the natural log of the absolute value of the crap in the denominator, which is x cubed plus 1. And it's going to be plus a constant of integration. And because the cubing function can be negative, I don't want to drop the absolute value sign off, so we leave it like it is.